Today, we are going to talk about the rotating cosmic filament. The largest spinning thread in the universe. For more than a century, astronomers believed that only small cosmic objects could rotate: planets, stars, black holes, galaxies. Rotation was something connected to gravity on a manageable scale. Something limited, something predictable. But in 2025, that understanding shattered. Astronomers discovered that one of the largest structures in the universe, an enormous cosmic filament stretching hundreds of millions of light years, is slowly rotating. Not spinning like a tornado, not twirling like a galaxy, but performing a cosmic rotation so large, so subtle, and so ancient that we weren't sure such a thing was even possible. This is not just another cosmic discovery. This is a rewriting of how the universe works. Today, we're exploring the rotating cosmic filament, the largest spinning structure humanity has ever found. What exactly is a cosmic filament? Before we talk about rotation, we need to understand the structure itself. The universe is not arranged randomly. Galaxies aren't sprinkled everywhere like dust. Instead, they form a giant network, the cosmic web. This web is made of galaxy clusters, voids, nodes, and filaments, long, thread-like structures stretching across unimaginable distances. A cosmic filament is basically a river of galaxies flowing through space in a massive linear stream. It can be between 100 to 500 million light-years long, and sometimes even more. Inside it you'll find galaxies moving like cars on a superhighway, dark matter forming invisible scaffolding, and hot gas stretching across the entire length. Think of it as a cosmic highway, connecting clusters across the universe. For years, scientists studied these filaments, but nobody expected them to rotate. Why? Because they're simply too big. The 2025 discovery of cosmic filament, the big breakthrough, came from a collaboration using the Sloan Digital Sky Survey, the Very Large Telescope, and new motion mapping software powered by AI. When researchers analyzed the movement of galaxies along one particular filament, they found something shocking. Galaxies on one side of the filament were moving slightly toward us, while galaxies on the opposite side were moving away. This is the signature of rotation. The entire filament, hundreds of millions of light years long, was slowly spinning like a gigantic cosmic drill. This wasn't a random swirl, it was coordinated, smooth, predictable, something that shouldn't be happening. How fast is this cosmic filament rotating? To be clear, this is not a fast spin. The structure rotates so slowly that one single rotation would take tens of billions of years, longer than the age of the universe. But on cosmic scales, rotation doesn't need to be fast to be powerful. Because we're dealing with trillions of solar masses in motion, thousands of galaxies, and vast amounts of dark matter. Even a tiny rotation velocity can represent unimaginable energy. Researchers found the outer edges of the filament move around 200 to 300 kilometers per second in opposite directions. The inner regions are more stable, and the rotation axis stretches across hundreds of millions of light years in human terms. This is like spinning a skyscraper, a mountain, a continent, and a solar system combined at once. The scale is incomprehensible. Why this rotating filament is so important? This discovery is not just cool, it challenges the foundation of cosmology. For decades, scientists assumed that small things rotate, medium things rotate, but the very largest structures are too stretched out to rotate. Why? Because nothing should be able to apply torque across such enormous distances. Yet here it is, a filament rotating as if something twisted it at the very beginning of the universe. This leads to new questions. Did dark matter give it a spin? Did early cosmic turbulence twist these structures? Did gravity's pull between clusters cause a slow pivot? Or was this rotation set during the Big Bang? The last question is the most mysterious, because if rotation is found in more filaments, it might mean the universe has a subtle, large-scale rotation built into its structure. Not enough to spin galaxies like tops, but enough to imprint momentum across hundreds of millions of light years. This could change our understanding of cosmic evolution. How something this large, like cosmic filament, even starts rotating. Scientists have three main theories explaining the rotation. 1. The cosmic vortex theory. In the early universe, matter was swirling due to uneven density. Some parts swirled more, some less. A filament might be the leftover result of a gigantic turbulence, like fossils of ancient cosmic storms. 2. Dark matter shear. Dark matter forms the skeleton of the cosmic web. If dark matter clumps were slightly uneven, they could twist the filament over billions of years. Imagine dark matter pulling the structure in opposite directions like a slow cosmic wrench. 3. Galactic inflow torque. Galaxies flow into filaments from cosmic voids. This inflow isn't perfectly balanced. If more galaxies fall from one side than the other, it can gradually add angular momentum. Like dropping rocks on one side of a spinning wheel, they slowly change its motion. None of these theories are proven, but the discovery forced scientists to rethink everything about cosmic scale motion. The future implications of cosmic filament. This discovery opens doors to massive possibilities for this filament. 1. The universe might have hidden patterns. If more rotating filaments are discovered, we might learn the universe has a preferred direction or subtle rotation. This would fundamentally change cosmology. 2. Dark matter's behavior could be revealed. Rotation at this scale could help scientists finally understand how dark matter clusters, how it flows, and how it shapes the universe. A rotating filament is like a fingerprint of dark matter physics. 3. Galaxy evolution could be influenced. Galaxies traveling along a spinning filament might accelerate, collide more frequently, and evolve differently depending on where they sit. These structures might be controlling galaxy destinies. For a long-term cosmic web mapping, future telescopes and AI-driven sky surveys will likely find more rotating filaments. This could lead to a new field of astronomy, cosmic scale kinematics. We might map the motion of the entire universe piece by piece. What happens to this cosmic filament rotation in the future? Over the next billions of years, the filament may continue rotating, become more stretched, feed galaxies into clusters, and act as a conveyor belt for star systems. Eventually, gravitational pull from the massive clusters it connects may tear parts of it apart, but that's not the dramatic part. The truly fascinating possibility is that our universe might be filled with dozens, maybe hundreds, of rotating filaments, and we've just detected the first one clearly. This is the cosmic equivalent of discovering the first exoplanet. Once we found one, thousands followed. The same might happen with rotating filaments, and if that's true, our understanding of the entire cosmic web is about to explode. Thoughts of cosmic filament. The rotating cosmic filament is more than just a scientific finding. It's a message hidden in the structure of the universe itself. It tells us that the cosmos is not still, not quiet, not motionless. Even the largest threads holding the universe together move, they twist, they turn, they evolve. They carry galaxies like leaves in a river. And if a structure hundreds of millions of light years long can rotate, what else out there is waiting to surprise us? The universe is not done revealing its secrets. And discoveries like this prove that we are only at the beginning of understanding how it truly works. Subscribe.